Hello, mathematicians. We're going to look at graphing linear inequalities in this lesson. So let's go ahead and look at our steps. So with our steps, we're going to graph boundary lines first. We're going to use a dashed line for less than or greater than, and we will use a solid line for less than or equal to, or greater than or equal to. Then we're going to test a point that's not on the boundary line. And we do need to make sure that the test point is not on the boundary line. My favorite point to test is 0, 0 if it's not on the boundary line. If it is on the boundary line, then I pick a new point or a different point. So it has to be a point not on the boundary line. And we're going to determine the truth value. Is that point a solution? And then we shade through what makes it true. All right, so let's go ahead and look at some examples. Here's our first one. We're going to graph y is less than or equal to 2x minus 1 in this coordinate plane. So the first thing we're going to do, step one, is we're going to graph this line, and we are going to use a solid line because we have a less than or equal to. So this we know has to be a solid line because when we look at this inequality, we have an or equal to relationship. So in this line, we have a y-intercept of -1, and we have a slope of 2 over 1. So from that y-intercept, we go up 2, right 1, up 2, right 1, or we could go down to left 1. And then we're going to sketch our line. All right, so now it's time to use a test point. I am going to use the test point 0, 0 because my boundary line does not go through 0, 0. And so we're going to determine if 0, 0 makes this true. So when y is 0, and we also have an x of 0. So substituting that into our inequality, we're going to determine, is this true? So is 0 less than or equal to 0 minus 1? Is 0 less than -1? No, it is not. 0 is not less than -1. So we cannot shade through 0, 0 because it doesn't make it true. We have to shade through the other direction. So we're going to shade the other direction because 0, 0 does not make this inequality true. Now we could also test a different point and then see that indeed we are shading through values that are true. If we tested another point, like for instance, let's test this point right here. This is the point 2, 0, and notice I shaded through this point, so it should be true. So if I test 2, 0, we would have 0 is less than or equal to 2 times 2 minus 1. And 0 is indeed less than or equal to 4 minus 1, which is 3. So this is a true statement. 0 is less than or equal to 3. So again, we shade through what makes it true. 0, 0 didn't make it true, so I didn't shade through it. 2, 0 made it true, so notice this is on the side of my line that is shaded. Let's look at another example. Here we're going to graph -x plus 2y is greater than 2. So here you have options. We could use x and y intercepts. So I'm going to find my x-intercept, and I'm also going to find my y-intercept. So recall, for our x-intercept, we have y equals 0, and when we have a y-intercept, x equals 0. So for this inequality, if we substitute 0 in for y, we have -x plus 2 times 0. Is that greater than, or, well, and actually, I'm going to set this equal because I'm finding my intercepts, not to 0. So the only thing I changed here when I found my intercept is I changed this to an equal because we want to graph the line, not the inequality quite yet. The inequality comes into play when we do shading. So here I have -x plus 0. So x equals -2. My step there, I divide by -1 or multiply by -1, right? And then I get x equals -2. So my x-intercept is at x equals -2 right there. Y-intercept, x equals 0. So that would be 0 in for x here. And so 2y equals 2, and therefore y equals 1. And again, the step here, divide by 2 in order to get that. So my y-intercept is at 1. So one way I could graph this inequality is to find my intercepts, and then from there, we can sketch what should be, in this case, we should have a dashed line. So we're going to have a dashed line that goes through those 2 points. Now, your other option is you could use slope-intercept form if you don't want to use your x and y intercepts that I showed here. So in order to do that, we would have to move that x over by adding. So we would have x plus 2, add x to move that over, and then we'd have to divide everything by 2. And if you do that, you'd have y equals, there's a 1 in front of that, so 1/2 x plus 1. And notice if we did that, we'd have a y-intercept of 1, which is what we have here, up 1, right 2, up 1, right 2. So or down 1, left 2. We still get the same dashed line. Now let's determine our truth values. So with this, I do not go through 0, 0. So I'm going to test 0, 0 because it's not a point on my boundary line. So when we test this point, I've got -x plus 2 times y. Is that greater than 2? Well, let's determine if it is. 0 plus 0 is 0. So is 0 greater than 2? Oh my goodness, it is not. So that means 0, 0 is not a solution. So I can't shade through 0, 0. I have to shade the other half plane, which is up here, not including 0, 0. Now, like I showed in the previous example, we could also test another point. So if we wanted to test another point that's in that shaded area, we could test this point, for instance. This is the point 0, 2. And if we test 0, 2, if we test 0, 2, we've got -x plus 2 times y. Is that greater than 2? And hopefully you see that indeed we have a true statement here. We have 0 plus 4, which is 4, and that is indeed greater than 2. So we can see that we shaded through the point that made this true. All right, couple more examples. Here we've got horizontal and vertical lines that come into play, so a little flashback to those. Here we have y is greater than -1. So notice this is going to be what type of line? We're going to have a dashed line here. So we're going to graph y is -1. So y equals -1 is right here. And when in doubt, remember, you can always find a few points where y is -1. So you could always graph like 0, -1, 1, -1. And you'd see, oh, I got some points here. We got a horizontal line. And then we're going to shade through what makes it true. So again, I can test 0, 0 because it's not on the boundary line. So if we test 0, 0, we get 0 is greater than -1, and that is a true statement. So we can shade through 0, 0 in this case because 0, 0 makes it true. So shade through that 0, 0, which is above this horizontal line. All right, now we have a vertical line and x is less than or equal to -4. So what type of line are we going to have here, dashed or solid? We are going to have a solid line because we have an or equal to. So x equals -4 right here, and on the vertical line that goes through that. All right, so I'm testing my point 0, 0 because it's not on the boundary line. So is 0 less than or equal to 4? You bet it is. So we're going to shade through what makes it true. We're going to shade through that 0, 0, which is on the right side of that vertical line. And we could also think through like what values of x are greater or are less than, oh, you know what? I wrote my inequality wrong. This is not supposed to be true. Do you notice my error here? Maybe you did. This should be a -4, so I need to rewrite that. That should be -4. Is 0 less than or equal to -4? No, it is not. So I cannot shade through this. That was not correctly shaded originally. Let's get that updated. All right, so as I was saying, we could also logic through like what values are less than -4, because we see in our inequality that all of these values have to be less than or equal to -4. So like -5, -6, all those are less than. 0 is not. So if we look at this and maybe we write it down correctly when we check, we end up seeing that. All right, let's look at one more here. So again, for this one, if you use x and y intercepts, we have an x and a y intercept of 0, 0, which doesn't really help us graph this because if we plug in 0 for y, we get 0. And if we plug in 0 for x, we get 0. So I'm going to need to use my slope intercept form in order to graph this. And when graphing this, we're going to have to employ one of our inequality rules from our math past. So please make sure you write this example down. All right, so the first thing I'm going to do is I'm going to subtract x. And so we have -2y is less than -x. And then we need y completely alone. So we're going to divide by -2. And when we do that, we get y equal, or y, and then there's a 1 here, right? So we'd have 1/2 x. Negative divided by negative is positive. Now we do have an inequality rule that tells us when we solve our inequality, we have to flip the inequality sign when we divide or multiply by a negative. This isn't exactly imperative to keep in mind in this situation because we always go through what makes it true when we go to the original inequality. But if you end up using this, you're going to end up seeing a different relationship here. So I employed the rule that tells us we have to flip the inequality if we divide or multiply by a negative. Again, not imperative. If we forget to do that necessarily, it's going to be okay. We could just have these equal and then graph this line and go back and check this. So anyway, I'm going to graph this line. We have a y-intercept of 0, which we would find already if we got our intercepts using x and y intercepts. And then up 1, right 2. Here, we do need what type of line? We need a dashed line. So we're going to have a dashed line. Now notice I go through 0, 0, so I can't test 0, 0. I have to pick another point. So any other point, I'm going to pick this point right here, which is the point 0, 1. So I'm going to test 0, 1. And when I substitute 0 in for x and 1 in for y, I need to determine, do I have a true statement? So 0 minus 2 is -2. This is a true statement. -2 is less than 0. So we're going to shade through what makes this true. So we will shade on this half plane right here. And you could pick any other point. Let's say you picked the point 2, 0 right here. You'd get a false statement, and 2, 0 would not make that inequality true, so you'd know to shade above. A type We're also going to be writing inequalities given the graph. So to write an inequality given the graph, we're first going to write the equation of the boundary line, and then we're going to test a point to determine that inequality relationship. We're going to use greater than or less than if we have a dashed line, and less than or equal to or greater than or equal to if we have a solid line. So let's go ahead and look at our first example here. With our first example, notice we have a solid line. So that means we will have an or equal to relationship when we get to that inequality part. So let's go ahead and just write this equation. So when we write this equation, we have a y-intercept of 4, so b is 4. And we have a slope. I'm just going to grab one other point here. We have a slope of 2 over 1, or 2. So rise 2, change in y is 2, change in x is 1. You could also, if you desire, grab those points. So we've got these 2 points are the points -1, 2 and 0, 4. And if we used our slope formula, you could also determine your slope by change in y over change in x. And we'd have 2 over 1, which is 2. So you could also use the formula. I think it's quicker to see the slope visually when you're given the graph. So that's why I did that first. I don't think the formula is as efficient. So, but you could use it if you want. Regardless of the method you choose to use, we have a slope of 2. So y equals 2x plus 4 is the equation of this boundary line. Now, I don't want an equals there. I want some kind of inequality. So we're going to determine what inequality will go there because we know a point that makes it true. So I'm going to use 0, 0, and I'm going to substitute this in to this relationship. So y is 0, x is 0. And I want to know what inequality has to go here. So 0 compares to 2 times 0 is 0 plus 4 is 4. So which one of these is greater? Well, 4 is greater, so it has to open to 4. And we know we have a solid line, so we must have an or equal to. And whatever that relationship is, we then put into our inequality. So our inequality is y is less than or equal to 2x plus 4. And we could, of course, test this. We could test a point in this inequality, any point in this shaded region, and we would see that all of these points make this inequality true. Let's look at one more. So here we have a dashed horizontal line. So this is the line y equals something. And here, y equals -1 in all of these points. So y equals -1 is the equation of just that boundary line. Now, we know it's an inequality, so we need to determine what inequality is going to go there. We have a dashed line, so dashed line means we're either going to have less than or greater than. So I'm going to test a point that makes it true. Let's look at this point. This is -2, actually 0, -2 technically, even though we don't have an x in this relationship. So here we know -2 makes this true. So -2, how does -2 compare to -1? Well, -2 is less than -1. So in our inequality, y is less than -1. So that inequality is y is less than -1. All right, good luck on your assignment. If you have questions, of course, please let me know.